Okay, this video is going to go ahead and basically explain how to solve equations by taking the square root of both sides. Now, in these equations, that we're going to go ahead and notice that there's going to be one term or binomial that is going to be squared. And to undo a square is that we can take the square root of that particular term and taking the square root of both sides of an equation to go ahead and solve for it. So let's go ahead and jump right into it and see where this takes us. So first things first is that in number one, the first thing I'm going to do is that I want to get x squared all by itself. So therefore, I want to kind of treat this as a linear equation and get the x squared by itself by doing the opposite operations. So add 5 to each side, and then divide by 2. And that's going to cancel out, and that's going to give us x squared equals 100. Now, to solve for this, what we want to do is that we want to take the square root of both sides, and if you watch the previous video, you'll understand why this works. So we'll take the square root of x squared and the square root of 100, and we're going to go ahead and get x equals plus or minus 10. And to go ahead and find out where the plus or minus comes from and why this works, you're going to have to watch the previous video in this series. This is just a video that shows the algebra and the steps to go ahead and solve the problem. Likewise, in number 2, you notice that we'll have the x that's in here, but we do have this squared part that is going to be the binomial squared, which we need to go ahead and take the square root of both sides, isolating just that binomial, and then, of course, taking the square root of both sides. So I'm going to start by adding 10 to both sides, and those guys will go out, and I'll have 4 times x plus 3 squared equals 4. Now, a lot of folks want to go ahead and use the distributive properties, but we can't if we have the binomial is raised to a power, as it's raised to the second power, so we can't do that. So our only option is to divide off the 4, like that. And over on the other side, we got 4 divided by 4, so I get x plus 3 squared equals 1. So now I'm going to pull out the heavy artillery and take the square root of both sides. And so dropping this down, I'm going to get x plus 3 equals now plus or minus 1. Now in this case, we have to go ahead, much like the quadratic formula, we have to go ahead and account for both the plus and the minus sign to solve for x. So that's going to leave us with a positive scenario for 1 and a negative. So I go x plus 3 equals a positive 1, and x plus 3 equals a negative 1. So that said, after subtracting 3 to both sides, I get x equals a negative 2, and x equals a negative 4. Oops, negative 4. So these are going to go ahead and be both of our solutions, and that's basically how you're going to have to deal with something that's a binomial squared, is by doing this whole operation right here, where you have a plus or minus scenario. The third example is going to go ahead and illustrate an example that has no solution. So we start like example number 2. We want to flush everything to the right-hand side, so I subtract 15. And when I subtract 15, I'm going to get x minus 1 squared equals a negative 16. Now, what I want to do is take the square root of both sides, but what happens is something that we've seen before, is that we have this part, which is going to end up being kind of a bad situation. We're trying to take the square root of a negative number, which means is that we're not going to have any real solutions over this. So if I'm asking you to go ahead and take the square root of a negative number, and it comes across that in the equation, we're going to have we have to say no real solutions. So, and just leave it as that, because the square root of a negative 16 is not going to go ahead and be a real number, so we stop right there. So, hopefully this gives you a taste of how to solve equations by taking the square root of both sides when you have just an x squared or a binomial squared. So, thank you for watching, and that's how you do that.